Guys, for all the solutions of this book, visit forthesakeofeducation.com. I've been working hard of putting all the problems into one convenient place for you to be able to do your homework easily. So pay us a visit.
To this problem that says the dimension of the jib crane, which is manufactured by this company, are given in the figure. Now it has a mass at a center G of 800 kilograms, so that will be right here. Let's call it the weight. The bearing at A is a bearing that can support a horizontal force only, and the bearings at B can support both a vertical and a horizontal force. Determine the maximum load of F that can be suspended if the selected bearings at A and B can sustain the maximum forces given right here. Okay, so first let's draw the free body diagram. You know that if you have a force here, this force is going to be trying to turn the whole jib crane clockwise, so the reaction at A is going to be horizontal, F of A. And at B we have a vertical, and we have a horizontal force that I know is going to go to the right because the only other force in the x direction, assuming this is x and this is y, is F of A, and it's going to the left. So B is going to be reacting to the right. F of B of x and F of B of y. So this is our free body diagram, and we want to know the maximum force that we can apply here. So the way I did this problem is simple. First, I'm going to do the sum of the forces in the x is equal to 0, right? So you know that minus F of A plus F of B of x, 0 is equal to minus of A plus F of B of x. So that would mean that F of B of x is equal to F of A of x, F of A, which means that F of B of x is equal to 24k, which is given right here, and F of A, given that F of A is at 24k, which is the maximum. So we're trying to find F of B of y and F, so let me go for picking B for getting rid of B, and I know that sum of the moments at B is equal to 0, that's a sum, and that is equal to the weight times 0.75, because it's B times the weight times this distance right here, and it's trying to turn it clockwise, so it's negative. And you know that the weight is given by the mass, which is 800 kilograms, times 9.81 meters per second square, which is the acceleration of gravity, and that gives you the newtons. So minus F times 3, because it's B times the distance from B to here, and that is 3 meters given right here, plus 24 times 2. So if you plug in the weight, which we calculate right here at, I think this is 7848 newtons. If you plug in the weight and you solve for F, you should get that F is equal to 14,038 newtons. But this is not the right answer yet. We know that this is the maximum force with F of A at max, right? But we don't know what force F of B is really holding. So we know that F of B has an x component and a y component, but F of B has a magnitude and direction on this way. Let's call it F of B, right? So we know that F of B is equal to 34 kilonewtons, and this is equal to the square root of F of B of x squared plus F of B of y squared. But this also basically means that F of B of y is equal to, remember, F of B of x we found right here. So we're gonna plug that in. And we plug that in and we solve for F of B of y, and we get that F of B of y is equal to the square root of 34k squared minus F of v of x squared. And f of v of x we have right here, and we plug that in, and we get that f of b of y is equal to 0.83.2 newtons, right? And now, with this value, we're going to do the sum of the forces in the y is equal to 0. You're going to see why in a second. So we know that f of b of y minus the weight minus f is equal to 0. So 24,083.2, which is what we just found, minus 7848 minus f is equal to 0. So if you solve for f, we get that f is equal to 16,235.2 newtons. Now we got two f's. Which one's the right answer, guys? The right answer, this is f of a with, this is f with fb at max, right? So that being said, we have two answers. We have when f of a is at max and when f of b is at max. And the right answer is going to be the smallest one. Why is it the smallest one? Because if we loaded with 16,235, then f of a was at max when the force was 14. So f of a is going to break. If this number was smaller, then this would have been the right answer. But since this number is smaller, this is the right answer. So I hope you guys understand this. So if anything, leave me a question on the comments below. Final answer.